So, Scott, today we're going to talk about this kind of, can we call it a Pythagorean anomaly, perhaps?
In a way, yeah. So this is this image is a comparison of three totally different phenomena. And what I noticed is they all have something in common. And I'll get to that. But let me just take you through each one of these cases so you understand where I'm coming from. In the first case, on the left, we have the cycle of fifths graphic. And this is a musical relationship. It's called the Pythagorean comma. And that is something that you'll learn about in musicology or in the theory of music, where 12 just perfect fifths are almost the same as 7 octaves, but they're not quite. It's off by a very small amount. And this is something that is really a little frustrating in music theory. Like, why isn't it perfect? You know? And this is something that is always kind of,
it's like a little gap or something.
It made me wonder.
Incomplete.
Yeah, it's a gap, and it's like, why doesn't it all work out perfectly? And so I was aware of that phenomenon, and I knew that the amount that these were off was about 1.4%. And I just put that on the shelf, you know. And then I was looking at the orbital mechanics of the Earth, Moon, Sun system, and thinking about how the year is 365.242 days in length, and yet the full circle is 360 degrees. And so it's a little bit frustrating again that the Earth's orbital period is not like a full circle. It's just a little bit more in terms of days. Wouldn't it be more pleasing if the Earth's orbit was exactly 360 days, so that each day would be 1 degree?
Yeah.
But it's just a little bit more. And how much more? About 1.4%.
The same amount.
Yeah. And so that kind of made me think, wait a minute, I remember that kind of vexing analogy from music. And here it is kind of in a totally different way, and it's off by the same amount. And then I was playing around with pi, phi, and e, which are these very important mathematical constants. And I was able to form a geometric relationship with them, and they almost form a perfect Pythagorean right triangle. But they're off by about 1.4%. And so all of these things kind of clicked in my mind through this inductive reasoning of just noticing patterns. And it starts to make me wonder about that gap.
Can I jump in, Scott, just before you go ahead, just because I want to bring people's attention to the piece of your diagram that really helped your point drop with me where I understood it. But you basically put the triangle, you see the phi, pi, and e triangle. It's a Pythagorean right angle triangle. And you were telling me that the hypotenuse, the pi line, has a little gap, which is almost just 1 pixel. And you were saying that this is actually done to scale, isn't it? Like, that's how tiny this gap is.
Yeah, so that little pixel there is in proportion. You know, I drew it in a CAD program. And so you can visually see how small that gap is.
Yeah. It's and really, how unsatisfying it is. Don't you just want to join that line?
Yeah.
Yeah.
But so you would call that maybe an imperfection or some kind of gap or something missing, right? But it makes me ponder that maybe there's a perfection in the imperfection at a higher level that we're just not intelligent enough to understand. Perhaps it's a higher dimension where everything is exact. And it makes me think about how the Fibonacci sequence is related to the golden ratio, in that when you have the Fibonacci sequence expressed in the real world, say in the seed pattern of a sunflower, it has to be expressed in whole seeds, right? Because you can't have a fraction of a seed, right? And so in the real world, things are off a little bit from the ideal golden ratio. And so all of these phenomenon are off just a little bit from some kind of template that's in a higher realm, perhaps. Yeah, go ahead.
Just bring you back to the diagram, right? So, you know, just to get really clear about what you're saying here. So there's there's three different unrelated phenomena. Yeah, they've got nothing to do with each other. One is from music.
Seemingly unrelated. Yeah,
seemingly
I'll give
unrelated.
you
Yeah,
a relationship in a moment, but go ahead.
But yet you've kind of said, well, maybe there is something in common between these three seemingly unrelated phenomena. You've got like each of them has a little gap or something missing, you could say. Yeah. And the little gap or the something missing in each of these unrelated phenomena is exactly the same. So now you start thinking, isn't that interesting? You know, so maybe these three phenomena are not as unrelated as we previously thought.
Well,
Maybe
that's what I was thinking, but I can't prove it because it's only 3 case examples. The sample size is very small here, and
but the
presumably there are
gap
a
is
lot of things
exactly
that
the
have a
same.
little gap, you know.
Yeah.
But the gap is 99.9% identical. So the gap
Identical.
isn't exactly the same, but it's really, really close.
Mm.
And so what unites these to me is the idea that, like Pythagoras had, that all is number. And so the transcendental mathematics diagram in the middle is about number in itself, right? And the diagram on the left, which is about music, is about number expressed in time. And the diagram on the right is about number expressed in space or space-time. And so you have all of these patterns emanating from number in itself. And I'm just noticing that in the case examples in the world, in music and in astronomy.
It's quite like the quadrivium, isn't it? Like the quadrivium is like geometry in, what is it, like mathematics, music, shape or form, and cosmology or something, isn't it?
Right.
And you've got three of them there. I'm wondering if we took just number in space, I think, is there a shape that would have a gap that's exactly
that
the
triangle.
same? Yeah.
So the number in itself would be the algebraic equations down below. Phi squared plus e squared divided by pi squared is this ratio.
Yeah.
And the number in space would really be the triangle. And the number in time, of course, is music, and number in space time is astronomy.
Do you feel, Scott, that all of this kind of like hints at like a glitch in the matrix? You know, that it's kind of like, what's with that error, that so-called error, you know, that shows up in all these different places, yet it's exactly the same error in inverted commas, you know?
Well, I think
that
it's like a powerful clue or Easter egg in a way in the matrix that points to the fact that there's more going on here than what we take at face value. You know, and I think
that's what it feels like to me.
This is a way of opening yourself up to that, but by looking in these different realms, these different whole domains of knowledge, and recognizing a similar pattern is reoccurring in each of these. So yeah, so I love this one. I think it's really rich and cohesive, and it's really vast in its implications.
I love it too. Yeah. Yeah. So please let us know what you think. We'd love to get some comments below. And also, if you haven't subscribed, please do. And we're going to be making more of these videos, and we'd love to share them with you.